Okay, so now here's lemma 2. Lemma 2 states a product of invertible matrices is invertible. If G and H are invertible and GH is defined, the product GH is invertible. And then we have G, of course, the inverse. How would we represent the inverse? So the inverse of GH, the product GH, is equal to H inverse times G inverse. Okay? So now the proof starts this way. It says because the two matrices are invertible, they are squared. That should be obvious, right? And because their product is defined, then guess what? They have to have the same dimensions. So let's say that they're both n by n matrices, right? Generalize it. So now we're going to fix the spaces and the bases, say Rn with the standard bases, to get maps G and H, which go from Rn to Rn, that are associated with the matrices G, which is written as a representation with respect to epsilon n, right? We're going from, the bases, right? Bases in the domain to the codomain. Again, we're talking about the natural bases here of G. So this is how we're going to represent G. And then likewise, we're going to represent H as the representation with respect to, again, En, epsilon n to epsilon n of H. Now, at that point, let's focus on mappings. Oops. Okay, so now let's consider H inverse G inverse. Okay? Now, by what we wrote at the bottom, okay, this composition is defined. Now, this map is a two-sided inverse of GH, right? So, this is a two-sided inverse of GH. Why? Well, because we're going to show you. So let's compose, let's take GH, right? Let's do H inverse, G inverse. Okay, let's do that. Now watch what happens. Well, now we can rewrite this as H inverse, G inverse, G times H, right? Well, this is going to compose and give us the identity mapping, right? So that'll be H inverse H. And of course, this is just going to be 1, so we're going to get H inverse H, which also gives us the identity mapping. Now, what if we do it the other way? Okay, let's compose it the other way. And GH times H inverse G inverse. Okay, same thing. We're going to get, oops. Like so, and then we're going to get in the identity mapping in the middle. And then of course this is going to give us G inverse, which again gives us the identity map. And so the matrices representing the maps reflect this equality. And we're done.